Good afternoon, everyone. So this is first of the recording session for Lab of Data Logic Design, subject code EC1833. So in this session, we will just see about the kind of experiments that we have to conduct and tools that we may use to conduct those experiments. So for the purpose of simulations in this subject or the topics related to in this subject, we will be using an open source electron design emulator, that is your Logisim. Okay, this is free to download and easy to install. Just need your Java plugin, updated Java plugin, and this is the website cburch.com, Logisim. Okay, so I will just write it here also uh, for you guys. I will just let me start. Okay, so the website is cburch.com dot com. Okay, so you can download Logisim from this website and do all the experiments on your own. Okay. So other than this tool, we will see the use of this tool in our lab and throughout these sessions. But there's one more other. If you are unable to download this tool due to some reasons, due to restrictions on your PC, like Java plugin is not working properly, you can also go for virtual lab developed by IIT Bombay. Okay. So once you open the website, that is vlabs.iitb.ac.in, and go for virtual labs in electronics communication. Okay, so you will see there are a number of labs developed by them. uh, Basically we will be working on this lab detail logic design. Okay, this is the list of experiments provided by them. Okay, so in this provided list of experiments, you can just go for adder circuit, multiplexer, decoder, and as per the syllabus, then comparator, latch and flip flops, registers, counters, multipliers, and state diagrams. Okay, so for today's session, we will just performing one of the experiments from this website. Okay, that is your adder circuit. Okay, I think most of you remember the theory behind these adder circuits, and but then also for the benefit of revision and to refresh our memories, let us discuss a little about these adders from the theoretical perspective. Okay, so I think this Jamboard is not working. This is very much lacking. So let us leave that Jamboard and we will write in this PPT. Okay, let it open. Give it a few minutes. Just adding some blank slides. Okay, so okay. So we were talking about this adder circuit. Okay, so what is adder circuit? uh, as we know, this is just a simple circuit which can add uh, two, let us say, signals of 1 bit each minimally, or this can go to 2 bit or 4 bit or 8 bit, depends on our application that we want to do, depends on our calculation that we want to do. Okay, so the basic diagram is something like this. Here you have got your first signal, here you have got second signal, say B, then here comes the sum as the output, and here comes the carry if it is present. So uh, mathematics happen like this, like A is 0 and B is 1. Adding this, you will get what? 1. Okay, so this one will come on this pin, that is S stands for sum and C stands for carry. Okay, so A and B are the inputs, S is the sum output, C is the carry output. Okay, so while before going further, let us see also how this summation happens. So 0 plus 0 will result in your what? 0. Okay, then 0 plus 1 will result in 1. Or 1 plus 0, 1 plus 0 will result in 1. Then 1 plus 1 will result in, if we were talking about decimal, then this will result in 2. But as we are not talking in base of 10 or decimal, we are talking in the base of 2 binary digits. So this will come as 0 1, where this at the LSB position 1 will go to some output, and this 0 will go to carry output. Okay, okay, so that means if I'm giving the input to this adder circuit as 1 and 1, okay, then the outputs will be, sum will be 1 and carry will be 0, like this. Okay, is it correct? Anyone? Hmm. Okay, if you are paying the attention in throughout my sessions, okay, just remember this. Okay, whenever two same bits 1 and 1 are added, 1 bit generate sum and 1 bits generate carry. Okay, so okay, just a moment, this is not 0 1, this will be 2, that is given as 1 0. So this 0 will go to sum and this one will go to carry. Okay, so this is sum and this is carry, and the output will be 1 as carry and 0 as sum. Okay, uh, so let us move back to the IT virtual labs. Okay, so this is the circuit, and okay, so that circuit diagram we have seen was just for half adder, and the circuit they are implementing here is full adder. I think you all know the theory about the half adder and full adder, so I don't think that I need to go in detail here. Just let us go to the procedure. Okay, so this is the procedure. You can read this on your own, and it is recommended that once you start using this website, read the procedure for every circuit. Okay, like what the procedure or instructions they are giving here. First, make a 1 bit half adder circuit and test it with different inputs. Okay, you should also try giving time varying waves as inputs and analyze the change in the outputs. Read the manual page carefully to learn how this can be done. Okay, so this is a manual page. Okay, this just gives the introduction uh, of the environment in which this experiments or this simulation is to be conducted. Okay, so you can just like see here that there will be various gate buttons, probes, or you can add or delete elements. You can add wires. Okay, okay, like you can save or load or print the output. Okay, so okay, then once you have done that, then you have next design one bit full adder. Okay, and in this manner you can just see, you can read it on your own. Okay, let's go to experiments. Okay, let's go to, it's not loading. Let's check for, make sure that your prerequisite installed to run experiments. Java Setting Browser 50 or its low version, Internet Explorer HT. Okay, so as I'm working currently on Chrome, it is here that it will work on Firefox. Okay, so let us go to Firefox. I will just copy paste here the link. Now I will just go to again here, add a circuit. I think it should work now. Experiments. ओके, सो आई वाज जस्ट चेकिंग आउट कि जो एडॉन्स वगैरह की प्रॉब्लम है वो मेरे पीसी पे सॉल्व हो पाती है क्या। ओके, तो वो नहीं हो रही है प्रॉपरली एंड दिस इज नॉट वर्किंग। देयर इज सम सिक्योरिटी कंसर्न। Okay, so you can see that almost all the settings are okay, but due to this same reason, I was just suggesting you guys, if this website doesn't properly work for you also, then you can go for this Logisim. To download it, just go to this link, download Logisim. Okay, and it will just download this exe. And once you have got this installed, okay, you can also see this documentation for this tutorials and all that. Okay, so okay, so let us move to Logisim for today's session. Okay, so this is the environment of Logisim. Here you have got your menus and then hand tool or arrow or text tool, and pins you have got logic gates, basic gates, and universal gates you have got here. Then there are basic many categories like wiring, gate, and others which you can use to design your own circuits. Okay. So as we were just designing a half header. Okay, so what happens in this circuit of half header? Let us first see uh, circuit diagram of half header. Okay, okay. So in a half header, what we have basically is one AND gate and one XOR gate. Both the inputs are simultaneously provided to both the gates and they carry as observed. Okay, so we have AND gate and we have OR gate, XOR gate. So let's come here. Uh, Let us from the gate category uh, pick one XOR gate. Okay, so this is your XOR gate and one AND gate. Okay, so by default you can see that there are 1 2 3 4 5 and 6 number of inputs and one output, and similarly here multiple inputs and one single output. But what we need is we need only two inputs. Okay, we need only two inputs. So select this, then in this header selection XOR, just come here and you can just make this number of inputs as like 2. Okay, 2, and the output will be in 0 or 1. Okay, no other setting needs to be changed. Okay, similarly do this same thing for this also and gate. Okay, now we need to place two inputs. Okay, so for the two inputs let us take this pin, or you can also from this input output take buttons you can also take. Okay, this you can also take. Okay, but rather than taking button it is recommended that you take pin. Okay, so this is my first pin, this is my second pin. Okay, let me write it as, this is my input A and this is my input B. Okay, now let's connect this again. take hand tool, oh sorry, arrow, or you can just take wire from here also. Okay, but need not select something separately, just select this arrow tool, and then from, so you can see this is highlighted. Okay, there's a slight highlight on the pin. Just drag it to here, and then like here. Okay, and this will also go to this one. Okay. Just click and drag and connect like this. Okay, and for the output indicators you just have to take this LED, place it here, connect, again take LED, place it here and connect. So this is your circuit, and XOR gives you the output for sum. So let's write this. This is your sum, and here light it carry. Okay. So now by pressing this, I can just go to this simulation mode, and if I just change it value 1, you can see that your circuit is now functional. Okay. So when we were talking about the inputs of this adder circuit, okay, so what were the input? We have two inputs. Okay, so if we are going to make a truth table like this, you have got sum, you have got carry. Okay, so 0 0 0 1 1 0 1 1, this will result in sum is 0, carry will be 0, this will be 1 and 0, this will be 1, this will be 0, but this will result in what, 2 in decimal, that is 1 0 in binary. Okay, 1 0 in binary. So this LSB will be taken as sum, so sum will be 0 and carry will be 1. Okay, so what is basically we can see here, okay, we will get 1 on carry only if both the inputs are high. Okay, so let us check this. Okay, so we are giving 0 and 0, we are getting the output side in 0 and 0. See, sum and carry both are 0 and both of the LEDs are off. Now as soon as I make A or B as 1, at least 1, then in both these cases my sum will be 1 and carry will be 0. So first let this make as 1. See, sum becomes 1, carry is 0. Again, if I make input B, then this is 1, this is 0, and you can also see that this highlighted branch shows the value on the wire. Like this wire, it is dark green means the value is 0, and light green, bright green means value is 1 on this wire, particular wire. And as soon as I make both of these inputs at 1, okay, you can see the sum goes low and the carry goes high, like from the truth table, sum is low and carry is high. Okay, clear? Okay, so this was all for the for this session. In next session we will just see uh, multi-bit adder or a full adder. Okay, multi-bit adder and a full adder. Okay, so this is all. And just to save also, you can just right click here and make it save as. Save, I'm making a folder on desktop. Okay, Logisim simulations. This is what my half adder, 1 bit. Okay, this is my 1 bit half adder. Just press it as save. Okay. One more thing that you can do for preparing your lab files is just uh, okay. See, for preparing lab files, one or two things are recommended. At least these files should be placed in such a manner that the connection is visible clearly, like this. Okay. So you can also just drag, just select the wire with a single click and drag them. Okay, as per your need. Like this wire is selected, drag it. This component is selected, drag it. This extra wire you can also select and delete. Okay. So like you can see this circuits now look somewhat matlab, readable, and it looks good. Okay. So this thing is recommended that you do this in every design. Okay, like this. Once you have done this, you can just go to this. You can just export the image in the GPF. Okay, do it. What is this? This was my half adder 1 bit export. So once you have exported this, you can just see that it will give you like this figure. Okay, it will give you figure like this. Okay, and for lab files, it is recommended that you do this also. Like you can write your name also, that it was made by, like you can write here, made by. Now if you just export it, and while exporting, remember that always to export in JPG, because this format is supported in most of the places. Okay, so once you have exported, let us check it out, and you can just, okay. So this line also gives you validation that this was conducted by you or designed by you, so no one else can copy this file for you. Okay. uh, so that's for all today. In next session we will see about the full adders or multi-bit adders. Okay. So okay, thank you guys.